Hello, and so here is part 3 for our chapter 5 video, where we're going to go over more rules and properties of probability. Now in the book, we start off by talking about, they go into this in a little bit more detail, and this is just going to be a brief thing. I would like you to we're going to go over these, but these start really getting into really more advanced stuff, especially into Bayes' theorem. I mean, Bayes' theorem is widely used in a lot of areas, and I think that if you really wanted to continue statistics, that's where you would go into. But for the purposes of this class, we're not going to be going into much more after the first 4 property rules. These, once again, are good to know, and we're going to go over them. But the first ones are the ones we're really going to hammer home. I am going to show a quick video or post a video for you all to look at for Bayes' theorem that goes into a little bit more detail, and it does get a lot more complicated because Bayes' theorem, as you'll see, really is the foundation for a lot of things we use today. Specifically, one specific that comes to mind is like insurance companies, or like with health insurance, knowing how much money you can get for life insurance depended upon your behaviors you have. So knowing if you are a smoker or if you have some other kind of chronic disease, the probability of you living longer with these things is how they generate this formula. And it goes into this crazy probability stuff that we use all the time, everywhere. And that's where it gets into a lot more advanced statistics. So I will post it, and you can watch it, and for your own knowledge. But for the purpose of this class, it will not necessarily be tested on, or things we will get into much more than this video. So when we talk about independent events here, we have events A and B are independent if and only if the probability of A and B are equal to the probability of A times the probability of B. For A and B to be independent, their joint probability must overlap just the right amount. This is notated mostly by all times we see with like a Venn diagram, and the portion we're seeing here is if this overlap can only be so much for us to determine if the events are independent. So much less think of independent events being independent. They, if, in order for someone to reach the age of 65, let's say, they have to be the age of 60. So 60 is a dependent variable to get to the age of 65. There has to be, you have to be dependent on something, or if it's going to be independent on something. So the general rule for addition, the general addition rule is the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. So most of the time, please be conscious of the word and or. A lot of times you'll see in statistics books, the probability, this might be probability of A union B is how they might notate it, and then the probability of A or B, or ununion B. So a lot of times we do this. Our book uses and or. I think it's a little bit more simplified versus using the symbols, which could confuse people more. But just letting you know. So the general addition rule is probability of A or B is equal to the probability of A plus B minus the probability of A and B. Conditional probability, let the probability or let this notation represent the conditional probability of B given A. So the probability of B given A is how we denote this. By this definition, as long as the probability of A is greater than 0. So this only works as long as the probability of A is greater than 0. So A has to be, there has to be a chance of getting A. It could be a very small % chance, but there has to be a chance for it. It can't be 0. General rule for multiplication. So we start with the definition of conditional probability, right, which is the probability of B, event B, given A. So the is equal to the probability of A and B over the probability of event A. Then we can rearrange the following formula as follows. The probability of A and B is equal to the probability of A times the probability of B given A. This is the general rule for multiplication, and all we did was take the conditional probability formula and rearrange it. And then lastly, Bayes' theorem, which we talked about earlier, which is the probability of A given B, probability of A and B over the probability of B, which then when we turn to Bayes' theorem, it's the probability of B given A times the probability of A over the quantity of the probability of B given A times the probability of A plus the probability of B given the complement of A times the probability of the complement A, the event not occurring. Remember, the complement of something is the event not occurring. So the probability of B given the complement of A times the probability of the complement A. Once again, this is where we get into the Bayes' theorem, and where you see this a lot is you'll see this a lot of times with insurance companies and figuring out things. This is the kind of the basis of how more real world statistics that get advanced go with how long will people live if you're a smoker versus a non-smoker. So the probability of smoking versus non-smoking, we can look at data and see, if you're a non-smoker, you tend to live longer than those who do smoke. Are you a risk taker? Do you have other chronic diseases or illness? Other past history, medical history. All these things take into account, and these are the events happening, so as the probability of living longer. Once again, this, like I said, this goes into a lot more detail. I will have a video up that I think does a really good job explaining it, and it'll be for you to watch, but once again, it's something that we won't go into much more than just this video. All right, hope you all have a great week, and study hard.